right, let me go ahead and grab this, but let me know if the stream sounds okay. Ideally, also, the latency should be a bit better tonight. So it's not quite the whole like minute and a half or whatever we were waiting. I went through and messed with that, so we'll see how that goes. But let me know if you guys can hear me okay, and if I sound and look fine, you can see my screen. I think we're gonna be just well, worst case, I'll just trust and hope that it's all doing okay, and we can go on ahead and take a look at what's going on. As live stream should be live now, I believe. Yeah. Looks like we're good. Oh well. I guess we'll just start this. And for whomever joins in can join in. So the goal of this week's sort of lecture, video, whatever you call it, is we're going to be looking at a few different common bugs that I've noticed within Fastai. Hello there. Awesome. We are not alone in this world. That makes me feel at least a little better. Let me see if I still have the. There we go. All right. Awesome. Just making sure I got everything all set up for what we're doing. So, as I sort of mentioned, we're going to be looking through a few common bugs that I've seen with the library. And they're really, at the end of the day, PyTorch bugs, just because of how PyTorch works now. We're going to take a look at a few of the Fastai magics when it comes to loss functions and special bits and bobs that it has. And then the last bit I want to touch on is loss metrics. While not directly related to loss functions in of themselves and the fact that they're metrics, it's a neat little class in FastAI that lets you use your loss function as metrics. So if you have more advanced loss functions that take into account, a few different losses, like file transfer, we can actually view each of those losses separately. We're going to look into that one. So the first thing we're going to look into is the whole X is not implemented for Y. Now, for this to make sense, I need to show you guys a few things. So we're going to just briefly make the pets data set. It's going to take a second to download. And I'm going to create a simple CNN learner. Right, we're going to call data loaders ResNet34, metrics of error rate. So we're not really going to train. We're more going to be looking at the predictor. And after this is all good to go, what I'm going to do is grab a batch of data. Because what I want us to focus on is the raw PyTorch happening underneath. So after this is all done, if we look at type X and type Y, so obviously we have a tensor image and a tensor category. And for those of you familiar with the new FastAI version and how all of it works, every single type of tensor has what's called a subclass. And PyTorch actually just recently integrated subclassing in, sort of helping us merge these abilities together. And so we can use these, just as regular tensors. So if I want to do, if I want to do simple inference, I might do, check real quick. honestly forgot if I grabbed a GPU instance. I did. So we'll do learn.model.CUDA, because don't forget that what we learned last week, the data loaders actually are the things the data loaders are actually what determines what device the model is on, and it happens during training. So we're gonna switch the model to CUDA ourselves. Then we're gonna do eval just because we want to get inference, and then we'll do out learn.model x. Standard PyTorch inference, right? Now we say look at out at 0. They're raw probabilities of, in our case, Boolean is something a dogger. I believe so. Dog or a cat. And now if you notice, this is a raw tensor, right? There is no, tensor category or tensor image that came out of this. And so what we can do then is, we can call the loss function and do, out y loss function. And now we get something called a TensorBase. Why do we have a TensorBase? Well, that's a special little Fastai tensor category that we're going to look into a little bit, as to why that's needed. Now, if we look at our loss function, by default, Fastai gave us flattened loss of cross interval. So this is a Fastai loss function. That flattened loss is sort of the key giveaway. Now, that being said, of course I can do, NN cross entropy loss, do my out and my y. And that works as well. And, now we no longer have a tensor base. We have a tensor category. So what exactly happened here? Because if we recall, the type of our out is just a regular tensor. So the deal with PyTorch in these subclasses is if it's a base tensor and something has a subclass, it's when you combine them together or do any sort of computations with them, it's going to want to try and use one of the subclasses, which in this case, it's tensor category. Now, this is still, a regular tensor, even though it might say tensor category. So we could do, well, in any case, it's still it's a regular tensor. What came out of our model was a regular tensor. So I can do, out argmax dim equals 1 to get, my classes. But let's go back to the whole TensorBase bit. So I mentioned that we now have tensor subclasses, right? So Fastai has like tensor mask, we have tensor category, we have, if we look at just tensor with a capital T, you can see every single one of these little subcategories that Fastai has, aside from capital T tensor. Now let's make tensor A, which is a tensor mask of just 1. And tensor B is a tensor category of 1. Now, let's say this was the output of my model, this was my y, right? Just for example. Now, if I wanted to combine these two together, right, I'd expect that to probably be 2, because it's 1 plus 1. And now we've hit that very fun error that many of you probably have found. Unsupported operand types for tensor mask and tensor category. Now, this is where the TensorBase comes into play. Because if I want to do any sort of computation with this, they need to have some form of the same type, even though in reality, if we look at tensor mask, it's a TensorBase eventually down the line. But right now, they're not, even though they kind of relate in the inheritance. So what we need to do is convert them into these tensor bases. Now, a nifty little function that Fastai has hidden away is contiguous, which does the following. All this really does, takes our tensor, converts it to a TensorBase. Now, where exactly I got this from? This is in Fastai's losses class. We can find it here. So now, for those of you that have probably tried using the base Fastai loss functions and found they work fine with, non-Fastai models and non-Fastai problems, but whenever you tried bringing in your PyTorch, all of a sudden things were breaking and you were getting these not implemented errors. This is why. Fastai will call this contiguous on all of our inputs. You can see it right here. Map contiguous to input and target. And so what this allows is if we do that, right? AB equals map contiguous AB. I can now do A plus B. The reason why is now they're all tensor bases. They're all the same type, and we can now work with them. The PyTorch just before 1.7, I believe, Fastai didn't need the special wrapper. We had all these different tensor types, and it all just worked out of the box. That's because PyTorch was very lenient in what it would allow you to get away with in regards to these subclasses. Now it's much more explicit, which probably isn't a bad thing. It leads to less headaches and less mistakes. Now, your next question on your mind is, okay, well, I'm casting to this TensorBase class. That means I'm going to lose all of my metadata. Well, let's see how true that is. So I'm going to give A the property of meta and say, this is my metadata. And we'll give B same meta and say, this is my other metadata. Now, if I do A plus B, and I look at its meta, it has A's meta, but not B. And if I do the reverse, it has the other metadata. So this is the first thing you should keep in mind if you want to keep track of, say, some particular metadata in your class or your losses. The first will dictate more or less the super subclass. And so A plus B means I add the value of B to A, but I keep A's metadata. So does that make sense? Technically, when you cast a tensor base, any metadata that is stored in the original tensor is always maintained. And then whenever you start doing various computations with it, certain classes will take over for particular values, depending on what gets added to what. Why do we need to do TensorBase transpose contiguous instead of just TensorBase to X? That is a wonderful question. So this is just given what I'm finding in the source code, right? Where we have it reading as self.axis, which this is like what the actual Fastai source code is. Now it's x.transpose axis -1 dot contiguous, right? And if we look by default, axis is set to -1. So let's see what happens if I do. Let's grab that A. That's fine. A dot transpose -1 -1. More or less what I have to say is that's just what Jeremy found. I don't necessarily 100% know the reasoning for it, but I presume it's just to make sure that all of the data is set in a way so it's similar to a batch to a certain extent. Because by this point, what's essentially going to happen is we then send this to our loss function. That's what this does right here if we don't go ahead and flatten. So that's my guess. I don't have an exact answer for you, sadly. Now, I want to do a different example with using a raw PyTorch model, and we can sort of explore the magic that Fastai is doing under the hood, even just with this little thing that we saw right here, because there is Fastai magic happening. So I'm going to take the standard ResNet, right? So I'm going to do ResNet 34. I'm going to say num classes dls.c. Now, this isn't, for those unfamiliar, this is not the same as what I call just here. This created a body and a custom FastAI head. This is where that magic. Whereas this is the raw PyTorch. Now, if I do torch nograd, right, net.eval, net.cuda, and then we'll say out PyTorch is our batch. If we look at the type of out Py, it's a torch tensor. All right, that's kind of expected, you would think. But now there might even still be some magic going on, even though it's just a raw PyTorch. So we're going to write a very basic dummy class, which I have stored away. But it's basically y equals mx plus b, right? We have y, or we have m here, x, and b. The very, very basic model. So I do net, lin model, and then I'll say my input is a tensor image of, all right? We're just going to pretend this is a very basic image model. Now, let's do some inference. There's where PyTorch is keeping our metadata and keeping our subclass. Sorry, not our metadata. Even though before we just got a raw tensor here, now we have a tensor image. Ah, hello, same. So why is this a thing now? Why, here did I get a raw tensor, but down here I got a tensor image? We're gonna rewrite this linear model, okay? And I'm gonna add one layer. Self.flatten equals flatten. Now, what the flatten class is, or the particular flatten layer, if we look at it, the docstring says flattened x to a single dimension at the end of a model. Now, this doesn't really tell me much, though, which makes me a little interested in just what's going on here. So let's go to where that is, fastai layers.py. Right, so we're going to go to layers. And I'm going to look at flatten. It's a little weird. And we can see that it's a class in a model definition. This is due to some fast core mod magic. But we can see that flatten does what we just did. View -1 if it's set to full. Otherwise, view to a particular size, also known as either unsqueeze or don't. But at the end of the day, we're casting to a TensorBase. And so we're taking that tensor image and bringing it to something we can use. So now if I did out equal this, and then return self.flatten out, now we have our TensorBase. And this was the importance of that full function. or that full parameter. So now that it's full, we have just the full tensor before we actually had a batch. So this is what's at the end of FastAI's special model. Because if we look at learn.model, there's that little flattened layer. And so that's why FastAI models will return a TensorBase and not a tensor image or just a tensor. Because by this point, it's still just a tensor image. This way, we can make the class of tensor into something that any loss function should be able to work with. So just to sort of repeat what the solution is, essentially, somewhere, write this little contiguous function. And then in your loss function, right, let's say I have A and B, little loss function. In the very beginning, just do map contiguous AB. And then you can do whatever operations you need afterwards. But this way, you don't run into this little unsupported type error of tensor mask, tensor category, or so on and so forth. This has been one of the biggest issues I've seen recently in regards to just general PyTorch issues since the new version. Are there any more questions about that and sort of what seems to be going on there? Although, Saeem, it looks like it's just you. So if there's any issues with that, you let me know. Otherwise, we're going to go over and look at loss metric. Now, the notebook that I'm looking at for the loss metrics portion of this is the style transfer notebook from my course, which I'm going to post in the chat. I can, open in Colab, and basically I remove 90% of what we don't. So the first thing I'm going to do is install FastAI. Go ahead and run that. Have a GPU select, right? It would be bad if I didn't. And basically, this first part of what I've written here is all the boilerplate that's wrapped away and, what's all going on here. This is just the minimal of what we need. And actually, we should probably do import FastAI. And essentially, this is a basic style transfer problem using a VGG19 as our sort of encoder. So what I'm doing right now is just downloading the model, getting the image, and generating a basic data loader for our loss function to work with. To get more in depth with this, I recommend watching my style transfer lesson, as it sort of gives you understanding of what's going on here. But I'm just going to go ahead and run all of these. And the basic idea is we have something called feature loss, right? This is my loss function. And in actuality, it's really two loss functions in one. It's this style loss and this activation loss. Now, if I just ran this like so, and I did loss function, grabbed some data, made my data block, so on and so forth, right? And I sort of trained, we can look at the results. All I show is my training loss and my validation loss. These, are my metrics in a way. But what if I don't want that to be? What if I want to keep track of, the mean squared error loss of my activation layers, which is what this activation loss is, and my style loss? What's a good way to do that? Because FastAI doesn't let me just do that out of the box, doesn't it? It does, actually. There is a special class called loss metric. So if we go to loss metric, search for that, find it in metrics, and then it'll be at the very bottom. It's this little loss metric. And here's the general idea. So if I have some arbitrary loss function, so in the example here, it's combine loss 1 and loss 2. And loss 1 is an L1, loss 2 is a mean squared error. Then what we need to do is store away each of those losses separately as attributes in our module. And then what we can do is I can declare my metrics as loss metrics and tell it what attributes to look for. And then whenever I'm training, it'll actually show me the various losses or our metrics. So let's go ahead and do that here. Now, for this particular problem, all that really requires is I just store away self.loss and self.actLoss, and then just replace anywhere I want to use it. Style loss, self.actLoss, y. Right. So now, rather than declaring my loss function as feature loss, actually, that's exactly what I need. Sorry. We'll declare the loss function as feature loss, and then metric is our loss metric. And we will say we want the style loss and the activation loss. Now you should make a string with comma separated for each of your metrics here. Now I've already, gotten the data. You can, examine it over in the style transfer lesson if you want. We have this particular issue because what should have happened is I stored away all of model information. However, it seems I did not. That's a little annoying. So we're going to go ahead and do a lot of copy paste. Really hoping I wouldn't have to do this, but the things that happen whenever you live, nothing ever particularly. So all of this is just the very basic style transfer model that actually Jeremy taught a few years back. It was the old part 2, where he sort of discussed the initial idea of style transfer without using a GAN, and instead using what's called feature loss, which is what this example uses and what I used in the course. Now, the model itself is this transformer net. And if we go ahead and fit for one epoch, this might accept we need metric. Okay. I moderately messed up. We need to name this different. So we'll call this SL and we will call this AL. Because I already named style loss, activation loss as their own actual features, as you can hear. So we'll just replace this with SL, AL, go back to our learner. Now, I might have messed up a little. Let's pull up the documentation for loss metric. The answer is it's loss metrics. Don't mind me, just use the wrong class. So now that we have loss metrics, we have our style loss and we have our activation loss. This is going to take, 6 or 7 minutes to run, but if you're dealing with a complex loss function, this is how you can use FastAI's little magic loss metric to sort of view how each of those losses are going during training. So maybe you might be doing, teacher training, teacher student, where you want to actually keep track of the teacher and the student loss to make sure that things don't go crazy, so on and so forth. And that's really kind of how you do that. And I sort of was helping someone on the forums the other day and on the Discord, and we brought up the question of what is loss metrics, and I'd never looked into it before. And it's a neat little class that Fastai lets you do. This way, it's not just reporting your 14 or your 16 the entire time. Instead, you actually get access to what is taking up those parts. And I'll be honest, that was kind of all I had planned for the evening. It's a quick little 30-minute stream. Just sort of wanted to show you this is what you can do, this is how you can do it. Ideally it's just a reference for you guys to look through. But besides that, thank you for watching. And these notebooks will be up in the Git repository for you guys to look at. So thank you very much. You all have a great evening.